In this video, we are going to kind of use our idea that we have about area under a curve and apply that to distance. So the table shows the velocity of a car at every 5 seconds over an interval of 30 seconds. So every 5 seconds, we're checking what the speed of the car is. We totaled a time of 30 seconds. The car's velocity is listed below. Use the table to estimate the distance the car traveled. So to understand how to do this, we have to understand the relationship between time, velocity, and distance. So velocity is distance divided by time, right? So the amount of feet it went divided by the seconds it took it to go that amount. So if I wanted to find distance, then distance would simply be velocity times time. So we're going to use this table and do velocity times time to estimate the distance traveled. So what we're going to do is look at the time intervals. So what I essentially have here is I have 6 time intervals, each of 5 seconds. Right? 0 to 5, 5 to 10, and so forth. So I have 6 time intervals, each of 5 seconds. So what I'm going to do is I'm going to first do an estimate where I do the left endpoint velocity, and I'm going to do this with 6 rectangles. So I'm going to say L base 6, and what that is saying is for this interval, for this time interval from 0 to 5, I'm going to use the velocity at time 0. So that first interval would have a width of 5 and a time interval of 5 and a velocity of 25. So we see the problem here is we don't know the velocity at like every single element of time over that interval. So I just have to say, well, from 0 to 5, let's use 25 as the velocity for that time interval. And then what I'm going to do is I'm going to say, okay, well, if I'm doing left endpoints, then that means from 5 to 10, I'm going to use my velocity at 5. So I'm going to add to this another 5-second interval where I'm going to say the velocity was 31. And I'm going to continue in this fashion. So from 10 to 15, using my left endpoint of my interval, I'm going to say, let's use the 35. So time interval 5, velocity 35. And hopefully you get the point here. From 15 to 20, that's another width of 5, and I'm going to use my velocity at 15 for that one, which would be 43. Another one of 5, and I'm going to use the left endpoint, which would be 47, so that's 20 to 25, use 47. And then from 25 to 30, I'm going to use the 46. And when I evaluate that, so I'm just going to do each one of those multiplications. I'm going to add all those together. What I end up with is 1,135 feet. That is using my left endpoints. Now, I could do the exact same thing using right endpoints. Okay, so I could say, well, let's go from 0 to 5. So again, it's going to have a width of 5, but instead of using my velocity at 0 for that one, I'm going to use my velocity at 5 for that one. And then from 10 to 15, from 5 to 10, I'm going to use my velocity at 10, which would be 35. And essentially what's going to happen is you're not going to have this one. You're going to have all the other ones because I'm now, like my left endpoints are shifted to now I'm doing the right endpoint in each one. So I'm going to use all those same values except for my last one from 25 to 30. I'm now going to be using the 41. So this is going to be 5 times 41. So I'm basically replacing the 5 times 25 with the 5 times 41. And I have all of my right endpoints. And if I do that, that gives me an estimate of 1,215 feet. Now, in a previous video, I talked about how we could do midpoints, and midpoints were typically the best, right? If we think about this scenario, we can't really use midpoints here with 6 intervals because, you know, I don't know what the velocity was at the midpoint of this interval. So like at time 2.5, I don't have in my table what the velocity was. So I can't say, well, let's just use the velocity at 2.5 for that first interval from 0 to 5. I can't do that. Okay, so I can't do midpoints with 6. I don't know that because, again, for that exact reason. However, I could say, well, instead of using 6 rectangles or 6 intervals, let me do just 3. Let me go 0 to 10, 10 to 20, 20 to 30. And now I could do midpoints. I would just have to do midpoints using only 3 time intervals instead of 6, because I would know that the midpoint between 0 and 10 is 5, and I have the velocity there. So that first one would be a time interval of 10, and the velocity that I would use there would be the velocity at the midpoint of that interval, which would be 31. And then I could say, well, from 10 to 20, that's again 10, and the velocity that I would use there would be the midpoint velocity, which would be 43. And then I could do from 20 to 30, the midpoint would be the velocity at 25. So that's acceptable as well. However, I will say in most cases, now this one actually gives us an estimate of 1200, which, because that's somewhere in between these two estimates, we might assume that that's the best answer. I will say this. It is typically better to use more rectangles or more intervals. So if I can say, let's use 6 intervals versus using 3 intervals, typically that's going to be better. Okay. Now again, midpoints are always going to be the better estimate as well. So a midpoint with 3 is going to maybe give us a close estimate to either left or right with 6, which it did. However, the overall thing is the more rectangles or more time intervals that you can make, the better. So we always want to try to make as many of those intervals as we can. But we also like to use midpoints. So those are all just estimates for that total distance traveled using time intervals and left, right, or mid points to determine those velocities.